All right, today we're going to continue 4-6 principal branches and trig, and today we're going to look at solving for composition functions, which means we're going to have a function inside another function. All right, so our first example here is we got inverse cosine of sine of 120. So like your order of operations, you generally want to start on the inside, so let's start on the inside. I want to figure out what sine of 120 is. So I would just figure out, okay, here's 120 degrees. My reference angle is 60. I know opposite 60 is root 3 over 2. And so sine of 120 is going to be root 3 over 2. So then this problem becomes, well, what is inverse cosine of root 3 over 2? Okay, so you know this is positive, and so we are strictly going to be in the first quadrant because remember inverse cosine's range falls in the first and the second quadrant, and cosine's x, and x is positive in the first quadrant. So we're looking for what angle when I take root 3, or when I take cosine of it, I get root 3 over 2. So hopefully we can see from the triangle we just drew that that means that this is going to be a 30-degree angle. And so our answer is 30 degrees. Okay, let's try another one. We got inverse sine of tangent of 135. So again, start out with the idea that 135 lands me in the second quadrant, gives me a reference angle of 45 degrees. So if I take tan of 45, I know that tan of 45 is just root 2 over 2 divided by root 2 over 2, or 1. But we're in the second quadrant, and we know the slope of that line is negative, so therefore tangent is negative. And so now I'm looking for inverse sine of -1. So you ask yourself, sine of what angle gives me -1? And so then you have to think, well, this isn't a triangle. This is our y value. Where is y -1? And hopefully we remember it's right down here at 270 degrees. But we can't use degrees because we can't use 270 because that is not in the range of inverse sine. So we actually have to use this angle right here, which ends up being -90 degrees. All right, let's keep going. All right, we now are going to get away from exact values. We're going to draw ourselves a picture. So when I do this, again, you always start with the inside. So inverse cosine of 3/5. So that's saying what angle when I take cosine of it gives me 3/5. So I would just draw a picture. Since it's positive, we know we're in the first quadrant. Cosine is adjacent over hypotenuse. So therefore my hypotenuse is 5, my adjacent is 3, and we do our Pythagorean theorem and come up with the idea that this side over here is 4. And so now if this whole thing is an angle measurement and we've got our picture drawn, then all we have to do is look at our picture and say, okay, well then I know tangent is opposite over adjacent, and so my answer is just simply 4/3. Okay, let's do this one. So I know, again, I'm in the first quadrant. Draw my triangle. This is my adjacent side. This is my hypotenuse. So then I have my adjacent side's 3. This is 5. I do my Pythagorean theorem to come up with this is 4. I know this is the angle that it's working at, because remember this whole thing is saying cosine of what angle gives me 3/5. So this answer to that question is just going to be an angle measurement. So if we know that's theta, then we just do sine of theta. And so sine of theta is going to be 4/5. And that's all you have to do. Okay, now we're going to write an expression. Okay, so same thing. I'm going to draw a picture. I know that this is the same thing as x over 1. And so I know this is my opposite side. And I know this is my adjacent, or sorry, my hypotenuse. So if I draw my triangle in here, my opposite side is x. This is theta. And my hypotenuse is 1. Well, the same way I got 4, I do the Pythagorean theorem, right? We'll just call this side a for right now. And I know that a squared plus x squared has to equal 1 squared, right? A squared plus b squared equals c squared. Pythagorean theorem. And now just solve for a. So I subtract over the x squared. I know 1 squared is 1. And then I got to get rid of the square root. So I take the square root of both sides. And a is equal to the square root of 1 minus x squared. So then on this side right here becomes 1 minus x squared. And so therefore if this all would give me an angle, because anytime you take inverse, you're always getting an answer for an angle. So this would give me this angle. Now my question just is, what is cosine of theta? And hopefully you can see that cosine of theta is just going to be the adjacent side, which is what we just found out by doing the Pythagorean theorem, over the hypotenuse. And you really don't need to divide by 1, so my answer is just the square root of 1 minus x squared. Let's do the same thing, but do sine of inverse tangent of x. Okay, stop the video, see if you can't figure this one out on your own, and then play again. Okay, so I would realize that tan, this is x over 1, and tan is opposite over adjacent. So when I draw out my triangle, I know my opposite side is x, my adjacent side is 1. Do the Pythagorean theorem, 1 squared plus x squared gives me c squared. And therefore, c ends up being the square root of 1 plus x squared. And if that is now theta, because that's how we drew the triangle to be, then we know that sine of theta is going to be opposite, which is x, over hypotenuse, which is the square root of 1 plus x squared. Some people may have you rationalize this. So if we do that, I multiply both the top and the bottom by 1 plus x squared, the square root of 1 plus x squared. And then the top becomes x times the square root of 1 plus x squared over 1 plus x squared. I probably would just leave it like this. Just depends on the format of the test or the format of your teacher. All right, so hopefully that is enough to get you started on the worksheet and the on your own problems, and we will catch up on this tomorrow. Have a nice night.